Now we're going to put in there as well the domain and the range for quadratic. And this, again, it's going to be pretty mundane to start with when we have just a regular quadratic, but it really becomes important that we take a look at this once we get to contextual problems, which we'll be doing in very shortly, actually. So let's just take a look at this regular parabola right here. Remember that the domain is a list of all possible x values for the relation. Okay, so what can x be? And again, this is what we've gone through when we did linear inequalities as well. Domain is still the same thing. It's a list of all possible x values for the relation, and range is going to be a list of all the possible y values for the relation. So domain is x and range is y, and I didn't put in my arrows when I print this off, so I'm gonna have to put them in now. There we go, there's my arrows. All right. Now, for a regular parabola, these two are regular parabolas. This one opens up, okay? All possible x values is every x value. This is going to keep on going up and up and up and up. It's going to keep on going to the right. It's going to keep on going to the left. So we're going to be able to go all the way up to positive infinity and all the way to negative infinity. Every x value is possible. Again, there's no context to it, so every single value is possible. Now, when we put that in there, what we're going to say is that x is a part of, and that's that little E type character again. And if it's going to be all numbers, it's going to be real numbers. So x is a part of the real number system. All numbers are possible. So R is all numbers. It's everything. It's decimals. It's crazy numbers. It's fractions. It's regular numbers. It's zero. Everything is possible. Okay. So this is our domain. Now the range is a little bit different. Not all y values are possible. There will not be any solutions when y is below 1. Okay, so for 0 or -1 or -2 or so on and so forth, there will be no possible y values. So the only y values are possible are from here and up. Okay, either up there or up there. All of those y values are possible, but nothing below. So what we can say is that y has to be greater than or equal to +1, because it'll be from +1 and up. So it's greater than or equal to +1. Now, same thing on this one here, or similar on this one here. Our domain, again, it keeps on going forever and ever. It doesn't stop. So our domain is going to be that x is all real numbers. Now, when we have a regular parabola with no context to it, it's always going to be this. So we're always going to have this. Once there's context, then it'll change. But for the time being, it's always going to be this right here. Our range will often look very similar as well. This is our top value of our range. It can't go above. So y is always going to be less than or equal to, in this case, +3, because that's our maximum value of y. So everything else will be less than the 3. So it could be equal to 3, but it will also be less. Just like in this one, it could be equal to 1 or more. This is our minimum value, so it'll be going up. So this right here is, again, our max, and this right here is our min. Okay, now again, just one little thing as well, I'm just going to show you. You notice how I put the point here on my parabola. Make sure you do that as well by clicking it and then taking a screenshot of that point. So just make sure that you're doing that when you are showing your graphs. Now, slightly more difficult with domain and range when we get to contextual problems. Contextual problems, there's going to be a specific range that matches a problem. So I'm just going to give you one right here that could possibly happen. Let's imagine that we have a soccer ball that has been kicked, and we're going to say it's been kicked right here. It's going to go like this, and it's going to land right there. Looks a little bit like a parabola, correct? Well, this parabola would technically continue that way and technically continue that way right there, and it's going to have some sort of max right there. Okay. Now, again, the parabola might continue, but our problem only represents this portion of the parabola, just this part, from here to here. So our domain is only going to be from here to here. Domain will be what our smallest value is of x, which is right here, and we're going to call that, I'm going to do this is going to be 0, 0, and this is going to be, let's say, 100, 0. That's our other intercept, and this will be 50, 20. Let's say it gets 20 yards high, or whatever the case is. Okay, so these are our significant points, our zeros and our vertex. Then our domain is going to be everything from 0 to 0. So our smallest value will be 0, and that'll be less than or equal to x, to our biggest value of 100. So this just says that x is greater than or equal to 100, it's bigger than 100, but x is also less than or equal to 100, sorry, greater than or equal to 0, bigger than 0, less than or equal to 100, it's less than 100. Okay, so it's got to be between those. That's what this says. X is between these two numbers. Okay, so that's what it represents with our domain. Range, on the other hand, is our y values. Okay, and you'll notice that our lowest one is down here and our top one is up there. So our smallest value of y is going to in fact be 0 in this case. And so again, we put y is greater than or equal to 0, but y is also less than or equal to our biggest value. So it's got to be between there, and that is 20. So our range would be from 0 to 20. So it goes from 0 to 20 and then back down to 0. That's our range. Those are the only possible y values that we could have in this question. So be careful with our domain and range. Domain is always the x values that are possible. If it's a regular parabola, that's everything. If it's a contextual one, it's between, it usually starts at 0 and ends at wherever it hits the ground. That tends to be our regular one. Sometimes it changes a little bit. Our range is always our y values, so our smallest y value possible and our biggest y value possible. Not the start and the end, our smallest and our biggest, because we might start higher than 0 and end at 0, so our smallest would be 0, or we might start at some level and kind of go from there. Okay, and then our top will always be kind of our maximum or the biggest value that we could possibly have in the situation. So domain and range, this needs to be a part of your graphs. When it's just regular, it's very straightforward. X is all real numbers, and then y is less than or greater than our max or min. But when we get to contextual problems, and we'll go through these a little bit later, then we have to be careful as to how we organize them.